There's no rush to it, or is there? If you don't understand me, please stop and ask. I don't mind you to interrupt me. You can also ask me in Malay if you want. Is there any international student here? Any student from the United Kingdom? Shafiq, you look like a US student. No. Okay, just in case, because we don't know. Maybe at certain times I will speak in Malay. Maybe some of you will get lost. But you can ask me, stop me, or because at the end of the day, what we want to do is for you to understand the subject matter. That's the cool thing about having online classes like this. We can also record so that if you need, you can go back to it, review it, or watch it again, and hopefully in the second or third time you'll get it. But then there's also you have your friends, your fellow classmates that you can ask. Maybe some of you guys will get it sooner than others. So that's the situation. From my experience, studying anything will take time for a lot of people. We don't talk about the truly gifted geniuses. Those maybe they don't even have to attend the class. They can study by themselves and get it right. But for most of us, the regular folks, I guess studying and being guided by an instructor would be the way to go. Okay, so my name is Shamsul Anwar Shamsuddin. You can call me Dr. Anwar, or because there are three Shamsuls in this faculty. We have Shamsul Faisal and Shamsul Azrai. They are the two Shamsuls. So I personally I like to go with Anwar, my middle name. But anywho, my office, maybe have any of you guys had me before, or maybe you was my PSM student. I guess who? Shahid is here. Mana Shahid ada? Shahid. Burdiono, maybe Burdiono is here. Faris. So, but for the rest of you, maybe I have never taught you anything. But maybe I was in your IDP or something like that. But anyway, it's nice to have you in this class. Historically speaking, usually I have a lot of people getting A's in this class, not because I'm a great teacher or something like that, but maybe because a lot of these topics you have already learned it in other classes, and maybe the skills and knowledge that you have gathered throughout this your study in UTEM maybe have prepared you for this one, and that's why I guess a lot of people get high marks or high score in this class. But in reality, for a lot of other people, this class is not going to be easy. It is very challenging, even for me when I was your age. Now I'm a lot older, during the golden age. But yeah, if you don't get it right away, don't beat yourself. That's normal. Maybe you have to change some approaches here and there. That is also a problem. But I only know one or two ways to teach. But if you don't get my way, you can try to look at other stuff on the internet or something like that, or there are a bunch of other books that you can refer to. Um, so let me share my screen. But if you need to see me personally or physically, you can come to my office on the 7th floor in the green building, FKM and or FTKM. And definitely, if I am here, I'm here. Otherwise, you have to contact me before you come to make sure that I'm around. Okay, but we can always communicate through the WhatsApp medium, and I'll try to get back or answer your questions as soon as possible. Okay, yeah, like I said, let me share my screen. Share screen. Oh no, share screen. Sorry, I've not used this for some time. Okay, now can you see my screen?
Can.
Okay, I'm gonna close my video because that might take some memory bandwidth, something like that. So I'm gonna open mechanisms. So there are two groups of mechanisms. One is you guys being the full-time students, and we have another group of part-time students. They are also taking this class, but unlike you guys, the part-timers, they have to study in a bit much faster pace because of they are also working. So I guess that also is going to affect their performance. Uh, what do I say here? No thanks. Okay, so I think I've put some stuff here. Is some information about the class. This some information about myself. You can contact me, but I prefer if you don't have to talk, you just message me. And let's take a look at this teaching plan. Teaching plan. Because as they said, fail to plan is planning to fail. Pernah dengar? Pepatah pujangga. What nama ni? Let's put that. Just put in download for now. Save it there. Okay. And open this kuliah for today. Not sure whether this slide that I have prepared here is the same as that one exactly. I guess it's going to be a little bit different, but I will share this version right after our class. Right after our class. Okay, other than that, we want to talk about teaching plan. Let's open that up. Okay. Can you see this clearly?
Boleh Doktor?
Boleh. All right.
Standard.
So, as usual, as always, we have three LOs. LO is learning outcomes. So basically, these are the targets that you should be able to achieve at the end of the semester. If you pass this class, you should be able to achieve this. So the first one will be for you to be able to describe the concepts and processes of designing mechanism systems, or at least maybe you can have some ability to understand the working of mechanisms. Okay, nanti kita tengoklah what examples of mechanisms, and then you must be able to analyze. So analyze will involve a lot of calculations. So this is based on the motion characteristics of the machine, and you use several methods to be able to do this via analytical method or graphical method and also computational method. Okay, computational method will involve that you use computer lah, but nowadays maybe even your handphone or tablet can also do the do the work. Okay, and the last LO is for you to be able to synthesize mechanism. So synthesize is another bombastic word for design, for you to able to design the mechanism. Okay, so usually you are be given um, ready-made mechanisms or mechanisms that already exist. So you analyze. But later on, at the end of the day, if you have already understood how to analyze it, you must be able to try to create a mechanism that will achieve what you want the machine to do. So that is the end game for learning anything. So first, you must be able to just follow the recipe, and then finally you can create your own recipe. So that's the situation in any any class or any knowledge. Okay, so as for the synopsis, I guess you can read. It involves some of the topics that we want to study, and I guess let's go down to some other stuff like maybe assessment. If I can get this thing to move, because this is a fairly old computer that I'm using, so it doesn't cooperate that uh, instantly. Take its own sweet time to follow my instruction. So how's the weather at home? Hujan? Sana hujan? Kat Melaka ni mendung. For today is overcast. It's cloudy. Okay, these are some of the references or the books that you can refer to. I would say a book by Dave Henry Mishka, is a good, I guess the best one. It's easy for you to understand. My approach will be very close to his way, but maybe I have some differences here and there. So I know Dave Mishka personally because he's a professor at the university where I studied, and he was in my doctoral committee. He's a cool big guy, and yeah, his book, I guess. Actually, if I'm not mistaken, he has a newer version. Maybe it was released in 2016 or something around that time. Uh, that should be the fifth edition, I would say. But for some reason, if you want to look for the PDF one, the cetak rompak one, I guess the easiest one will be to find this one. Other than that, book by Robert Norton is also another good book. Robert Norton is a professor at the Institute of Worcester Polytechnic Institute, something like that. Worcester. And another cool book is by John Uiker or John Vicker, Vicker, J.J. Pennock, and Shigley. Shigley has already died a long time ago. But I guess this book by John Vicker is based on the work of John Shigley or Joseph Shigley. The latest version that they have is in 2023, Theory of Machines and Mechanism. I used this book when I was in my undergraduate. So, but that time it was by Shigley. But even back in 1995, Shigley has already died. Professor Shigley was a professor in University of Michigan in Ann Arbor. Then a book by Waldron and Kinzel is also another good book. Erdmann, Sandor, and Kota is also another cool book. And perhaps there are a few other books that you can look for. So if you want, you search for mechanisms or kinematics. Um, mechanism or kinematics. I'm sure that there are a lot of other books around, but these five books also are the top one. The top one. See, it's not responding. Okay, so this is a 3 credit hour. So our lecture is usually around 3 hours per week. But usually it's less than that. But like I said, you still need a lot of time outside of the class, outside of our meeting for you to be able to understand the material. Okay, for assessments, basically we have one midterm test, and in that we have 2 questions, giving a total of 20% for that midterm test, mid-semester test. And then we have this final exam where you get 5 questions and you have to answer 4. So that would be 60%. And then I'll give you a bunch of assignments for you to enhance your understanding. So I think if you are able to do the assignment or the homework, I call it homework, that should prepare you to answer the questions in the test and also the final exam. Okay, I think that's the deal that I want to give to you. So is that a good deal or not? I hope it is. I hope it is. Okay. Next, we want to talk about the planning. Like they say, failure to plan is planning to fail, something like that. Okay, but this is just a rough estimation, rough planning. We'll try to stick as close as possible to this plan, but there can always be some changes here and there. So for the first week, we'll cover this topic from this um, from knowing about kinematic diagrams, kinematic inversion, things about degrees of freedom. When we talk about machine links, joints. Okay, so a lot of these are already in the slide that I shared. And then for next week, we'll talk about some other tools that will be used or will be employed in especially in analysis. So mostly concerning vectors, because not many people like to use vectors for some reason. Do I have any fan of vectors? Okay. Maybe you have to learn it before you can decide whether you are a big fan or not. Then I will also try to utilize the use of MATLAB. MATLAB is a software, and believe me, MATLAB is not the uh, pain in the neck software, programming software like probably what you have used before, not like C++ or Fortran or Pascal. I guess MATLAB is much easier than that. I think you have to explore it in order for you to love it. Plus, the university has already bought MATLAB campus-wide license for staff and also students to download and install on your own PC or laptop. So might as well use it before that that privilege is being taken away. Okay, so hopefully next week we will try to explore that. And the third week, I guess the week of Hari Raya, we'll talk about velocity. I'm not sure we want to talk about velocity during the Hari Raya while you eat ketupat and rendang. Rendang, you like rendang? Or soto, masal lodeh? Sounds very delicious. Okay, so and then the fourth week when we are supposed to meet face to face, physically. So we'll talk about acceleration. So acceleration is a very tough one, and usually it's a time-consuming stuff. So we'll do that after Raya when you are full, your tummy is full. So hopefully you have the energy to wrestle with this very tough topic of acceleration, linkage acceleration. Good one. And then the fifth week we'll talk about the gist of this class, which is mechanism synthesis. So you cannot do mechanism design without this one. So this is the heart and soul of mechanism design. So if you get this fifth topic, I guess you can pat yourself at the back. And this is the main thing for you to be able to do. I guess in real life, as you go on in your career, probably this is the main thing that could probably help you in your career as an engineer. Because a lot of other analytical stuff, you can also use other means, especially like computer method or something like that. You can use CAD. But this one is requires you to use your brain even more than the other stuff. And it can also use a lot of creativity here. It's not just analytical stuff. Okay, and then other stuff. So after, before the break, I guess Where are we at? When we get to chapter 6, we are actually um, in the things that you have already seen before, like the topic of gear. Maybe the topic of linkage is not, you have not seen it before in other classes, but the sixth chapter here is gear, and probably you have seen this. Maybe if you did your diploma, you've seen it in machine design or mechanic machine or something like that. Or in other mechanical design. So in your third year in mechanical design, you have already learned gear. But here the emphasis will be just on the working of it, the motion of it, and also a little bit on the apa nama tu? On the gear force, on the gear force. Okay. Okay, and with it, we have our semester break. Semester break. Good times. And then week 9 and 10, we'll continue our learning in these topics of threaded mechanism, screws, and also cam and followers. So these are very, especially the cam one is very design heavy, emphasis on the design part. And then we'll touch another familiar topic, belt and also chain. Maybe the chain part was not covered in the mechanical design, so uh, we will emphasis more on the chain part because belt you have already seen in mechanical design. And there are some other stuff like apa nama tu? Geneva cam or Geneva wheel, and like that can give you intermittent motion, and also ratchet and pawl. So this some other topics that we might touch. Okay, and then in week 13, we'll touch the topic of forces, and this should bring you back to statics class. So if you did not get an A in the statics, you try to get a revenge over here. Cool revenge. So maybe I'll try to introduce some alternative method on how to solve static forces here. If you like it, that's fine. Otherwise, I'll try to use what you have learned in statics. And you can also relate the forces here to the topic of gear, because like I said, gear forces will also be a focus. And then in the final 2 weeks of the semester, we'll try to look back on the use of MATLAB and also other tools. Maybe you can use SolidWorks or something like that. Those, they are a bunch of other capabilities in either software that you can install or online software that can help you in doing this kinematics. And then there's also the topic of forward and inverse kinematics that can also be related to robot application. So does that sound interesting to you so far about what you are about to see throughout this semester? Or is this a big turn off and you feel like dropping this at the first instant that you get? Okay, I hope you are not being discouraged, disheartened by this revelation, and you'll keep on continue to study this class. And like I said, a lot of people get A's for this class for some reason, even though it's supposed to be scary class, but it turned out not to be. So if this is my email if you need to email me anything. And yeah, there's something here. A lot of design electives have already abolished their final exam component, but not this one. I thought about it, but since I did not do any any paperwork to this end, so I have to maintain the final exam for now. And like I said, try to have 5 graded homework on a bunch of different topics that should be helping you to understand the whole material. Okay, do you have any questions so far? No?
No question,
No
Doctor.
question. Are you guys sleeping or are you guys with me?
I'm with you, Doctor.
All right.
Don't worry.
All right. Let's push ahead. Let's get on with this class. We have it's already 11:45, and let's get to the sweet part of this class of this first lecture. Okay, basic kinematics. Right. So the term kinematics is generally can be defined as a study of geometry and geometry of motion. So hopefully our focus will be on rigid body. Okay. So because rigid body, the shape of that body will be maintained. So when this thing move, it will try to maintain the shape of all the components that make that body. And so whatever angle that thing turns, or that body turns or translate, um, translate means it goes in x, y, or z, but in a straight line. That is called translation. And rotation means it has to move lah, rotate along certain axis. Okay, so you need to know how many degrees it turns along that, or around what point it turns. So, but as long as it is rigid, that things, all the components that make that body will maintain the same shape, angle, and also length. Okay, because not everything is rigid. Like if you make something with a piece of paper, so paper, it is physically solid, but it is flimsy, it is flexible, something like that. So it's not rigid body. The same thing with belt or chain. So those are flexible mechanism or flexible component. Okay, they are not rigid. So, but when we utilize chain or belt, we want it to be stretched or in tension, because only when they are in tension that they can uh, perform something useful for us. So in that situation, when they are in tension, they become we can treat them as rigid body. Okay, do you understand? So the term kinematics and mechanism is sometimes used interchangeably. Okay, but for us engineers or engineer to be, we I guess give more emphasis on referring to this stuff as a mechanism or mechanism of the machine. Uh, Whereas people in the more mathematical field of study, they will look at this from kinematics perspective. Okay, so for for us, I guess the word that we emphasize more is the word mechanism instead of kinematics. So, okay, but here there's another definition for mechanism. It's a study of techniques. So here we look at the techniques for analysis and dimensional synthesis. So we must be able to analyze and also to synthesize the linkages and other mechanisms such as cams, gears, and other moving elements, machine elements, and that is supposed to do certain motion. Okay, so something not many not all elements need to move. So when it is not moving, it is a structure. So that is not in the concern of our study here. Sometimes when we want to build buildings or bridges, uh, we don't want them to move. We want them to be fixed. But although from another minor perspective, we acknowledge that by climate and weather, when we have cold and cold climate, things can expand and things like that. So we must be able um, to expect some movement, small movement. Otherwise, the structure can break. But they don't move that much. They don't move that much. And also for if you building something structure in places that are earthquake prone, so they must be able to move in certain way to avoid catastrophic collapse during earthquake. So, but for machines that are going to move, you expect them to move, such as this lift. This lift. So when you want the car to get on it, so you have to lower the lift here, and then only the car can get on it, on top of it, on top of this base or platform, and then only you can raise the car up for technicians or foremen to able to work on it from beneath. Okay, so like you see, the term mechanism here is a little bit different from kinematics, but like I said, they are also used interchangeably. So sometimes you don't know which one is which, but basically they are talking about the same thing. But the term kinematics will focus more emphasis on the mathematics of it, geometrical mathematics of it, whereas mechanism will look at different methods to understand this thing and also to design it. Okay. Then we have this. Okay, so what are mechanisms? What are mechanisms? So these are some example. Okay, like that one is also another example. So anything that you see machine that moves, or maybe you don't see the moving parts because they have a cover, like your engine, car engine. You don't see the piston moving inside it, but if you uncover those things, they a lot of moving parts inside it. So that means it is the mechanism. So all these are the subsystem of the mechanism. Some are very complicated one, such as this engine, piston, the connecting rod, and then you have this link over here, which is the crankshaft, and also can be as simple as this clamp. So do you understand all these things? So later we will see how we want to categorize these two type of mechanism. They, as you can see, they move a lot, and but this one has a slider. This one doesn't. Okay, so if you read in this field of study, you'll find that these two are representing the basic type of mechanisms, linkage mechanism. Okay, why do we study linkage mechanism first? Because not because it is easy. It is not easy. Therefore, I guess a lot of schools they kind of avoid this topic. But in actuality, I guess you see a lot of this in engineering work. Okay, so we don't want to have our graduates not equipped with this knowledge. So you want to be able to uh, to realize that this is important stuff. Like you guys are taking this class as an elective. Okay, so you will learn about these things. That's good. And if you remember when you took mechanical design in third year, you have this topic also. So probably you have seen this same lecture, but it wasn't like that a long, long time ago in the galaxy far, far away. No, no, not in this galaxy. So this topic was not uh, in mechanical design. Back then, it was called machine component design. Okay, so and only student who took mechanism design will see this thing, this topic. So if you're not from this class, not taking this elective, so you will never learn this thing. So I was among the lecturers who proposed that this topic is included in as a general mechanical design course, so that everybody, uh, regardless of what elective that you are supposed to take, you will also learn this topic. Because I see this should be very basic mechanical knowledge that every mechanical engineering student graduate should be able to understand and realize its importance. Okay, even though it might not be easy. Okay, so just recap since you already learned this in mechanical design. So this is called the 4-bar mechanism. And you see the part that doesn't move is the base, and that is also part of the link. And then you have this small link over there, that's second link. Third link is over here with the handle. And the clamping part, which is the output, is the fourth one. So 4 members in this 4-bar mechanism without any slider. Whereas this one, you have the red one colored here as the first link. So that is easily omitted, but it is there. So second link will be the crankshaft, third link will be the connecting rod, and then the fourth one is the piston, which is the slider. So this is also a 4-bar mechanism, but since it has a slider, so we call it a slider crank mechanism. So these are the most basic part of mechanism. The maybe 2-bar mechanism pun ada, but it's not going to be that interesting to learn. That one will be very easy, but of the one that is should be the focus of our study. It will be the 4-bar mechanism, also the slider crank. Okay, and for each of the member will be connected to the next member through joints. So we have two type of basic joints. One is called the revolute joint with the symbol R. So you see these pins over there. So those are the pin joints, or we call it revolute joint. So that is very we can see that physically visible. And also here we have another pin, and there's also another pin here between the the crankshaft and also the ground. So that's another pin, and also between the connecting rod to the piston, there's another pin. Okay. So when we talk about joints, it is about relationship, not just the physical part, but it's more focused on the relationship, on how this thing relate to the surrounding. Such as this one, even if you see the piston is uh, sliding back and forth like that, we know that it is not going to be just floating in the air. It is supposed to be sliding on something, or on the ground, sliding inside a cylinder or something like that. So it is about a relationship on of how this thing relate to the next item or next surrounding. Surround. Okay, in this case, it is sliding in a straight manner. Can also be sliding in a non-straight or a curve line, because I have seen some engine piston that slides in a circular manner. So that's a bit non-traditional kind of engines. Non-traditional engines. Uh, there are some like that, but not that common. Okay, this R and also P joints, or revolute and prismatic joint. Revolute is the pin, and prismatic is the slider. Uh, is
Doktor,
called the J1. Okay, apa dia?
sorry doktor, ada student yang tak dapat lagi join untuk kelas
Okay,
ni
I need
sebab
to
diorang
approve
ada
them.
pending lagi.
Okay, let me stop this. And how do I get back to that? To go here. How to approve that? Tadi I have to go to. Hmm. Macam mana nak approve tadi? Tadi saya klik dekat activity. Pending request. Oh, this people. Haikal. So I need to click that, that. So try click accept all pun tadi tak boleh lah. Okay, hope that does it. Okay, for those who just joined us, welcome to the show. Can you see my screen? Boleh?
Boleh Doktor.
Boleh Doktor, boleh.
Okay. So let's get back to the lecture. Okay, so this type of relationship, the pin that allows you one part to rotate with respect to the other part is called revolute. The part that allows you to slide to the next part is called the prismatic. So R and P is categorized as J1. J1. And then we have another category that is called J2. Okay, so this is also important. So J2 is all that can be categorized here. We have this one is cam. Cam. So here you see why it is a J2. It has something when it is in contact. It is sliding as well as it is pushing it linearly. Sliding and linear. Okay. Here also, when you look into gear, as one teeth or one tooth meets with another tooth on the opposing or meshing gear, it is going to slide and also push. Slide and also push. So there are two things happening when they are in contact. Okay. Same here. When you have this pin enter into the slot, will slide inside that slot and also at the same time push it to rotate. Okay, you see over here in this animation. So I guess a lot of this thing that we learned in this class, it is very helpful if you can look for the animation or GIF or GIF. Okay, so actually there's another one missing here. So I should add screw. Screw also is included. Screw is also included. Screw. Why is screw included? Should I put SpongeBob there? Animation GIF. Bunch of GIF here. Anything that involves screw here? Tram ada. Any Trump supporter here? Any MAGA supporter? Not there. Screw. Let me show why screw is also should be included. Maybe not on this computer. Okay, but definitely screw should be there lah. Animation screw and screw. Maybe I can use this one. For the moment, maybe I can just include this animation. Maybe add another. So this one, cut and put over here. Screw. Okay, let's see why screw is so, but this one maybe have to also include another uh, one. This one is almost like a screw, but it's not really screw. It's actually a gear. We call it a worm gear, but I guess the base is also a screw lah. Okay, here you see as this screw in contact with another component, usually a nut. So there is going to be a rubbing or friction when they are in contact between the tooth of one or thread of one screw and the thread of the nut. Okay, and also at the same time it'll be pushing it. So there's two things happening there: rubbing or touching and or in contact, and also pushing. Okay, same here. As it is in contact, there's some rotation, and also pushing. So that is what allow this circular gear to rotate. Okay, so that is the situation. So that's why this screw is also in the J2 category. Same as the cam and also the pin in slot and gear. So when we want to identify if there is any J2, so ask yourself, do we see any cams? Do you see any gear? Do you see any pin in slot? Or do you see any screw? If you see only this one, so they are J1. RNPs are J1. Okay, so this will be preparing you for the next part, which is you when you have to use a certain equation to do some calculation. Okay, so sudah panas sudah makin susah awal-awal lagi dah susah ya ke okey lagi ni you guys
Boleh
still
Doktor. Okay,
can
okay.
follow me okay 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 all right okay okay this is actually a picture of connecting rod connecting rod like the one that we see in the engine application especially piston engine piston engine because there are a lot of other type of engines piston engine so piston engine will employ like this so what makes it binary because there are two places or two end that we can put pins and obviously they are of different size one is smaller one is bigger pins okay so but kinematically we don't care what is the shape of it or what is the size of it kinematically we just represent them as this as simple as this one I don't care if this thing is crooked looks at an S shape or something like that. But as long as what matters is the position of one pin to another pin, one pin to another pin, so we can just represent it with a straight line. And we call it a binary link. Okay, so this is the most basic of type. The basic type doesn't get any simpler than this. Okay, this is called binary. Binary so means two. So means there are 2 points that is very interesting for you to locate. And usually those 2 points are places where you can put pins, pins, and will allow it to be connected to another component. Okay. Okay, and then we have if the components, if that one piece of body has 3 places where we can put pins, 3 places where you can put pins, or either pins or maybe there are places of interest, point of interest, point of interest, POI. Kalau polis lain lah, POI, person of interest. So before they turn it into a suspect, they they want to call for questioning, for interrogation. So person of interest. Okay, so if you look at this piece of plier, flexible pliers, this component over here in the top part, we can identify actually, maybe not that obvious, but this one is obvious. We see one place where we can call it a pin, maybe it's a rivet or something like that. So, but that rivet is can be acting as a pin. And actually, one over here is not that obvious because probably the head of the pin is not shown, cannot be seen. But definitely because it is connecting or connected with this other element, which is this is a binary because it has 2 places that we can attach pins. Meaning over here must be a pin over here to connect to the top part. So another pin over here. So 1 and 2, and actually this part is the third one. So this one doesn't have a pin, but it is a point of interest. So why is it a point of interest? Because if you want to hold a whole workpiece, hold a nut or a bolt or something like that. So this is a very important part that you want to track. You want to track. So kalau tak ada this part is not going to be complete component. Okay. So a link is you can track whether how many places you can put pins or what is the point of interest that you can track. Okay. Over here, this lower jaw is also another ternary link. Because for the lower jaw to connect to the top part or top jaw, here must be a point, a pin or revolute joint. Over here is another revolute joint or a pin connecting it to the gripper, bottom gripper, and over here another point of interest. Okay, even the gripper is also a ternary link. It has one pin there, a second pin there, and another over here is a point of interest where you want to track your fingers, finger of the user. Okay, ada question tak? Why this thing is called ternary link? Okay. Actually, what is important is not the name lah, whether it's binary, ternary, and over here quaternary. What is important because is for you to understand that this is actually one body, but it has 3 points. This is one body, it has 2 points. Later we can have one body. It has 4 points, and the name is given as quaternary. But it is not going to be limited to these three. Can have many other number of points, and I don't know what name to call them. So like I said, what name is not important here, but for you to be able to identify how many points for you to put the pins or to track as a point of interest. Like for this member over here, this boom or piece of metal in the middle of this excavator, how many points that it has. So if you want to track, you will find that they have many, or even this front boom over here. If you can track my cursor here, my arrow there. So that one has one over here, one so let's go laser like Star Wars. So over here, 1, 2, 3, 4, and 5. So this piece of boom, BOOM, this piece of boom has 5 points. So what name to call it? Pentanary. So who cares about what name to call? I guess as long as you know how many points are there, that matters. That is what is important. Like this one with the Vogelbau label over on it. So probably there's one over here, 2, 3 for this cylinder, and 4. So this will be quaternary. So 1, 2, 3, and 4. Okay. In sometimes on the machine you see some duplicates. Like here, if you can zoom your attention on this part where we have this cylinder, hydraulic cylinder. So you have two identical hydraulic cylinders there, but actually they are doing the same thing. Whereas this one on this part it has only one. So, and if you see the size of this one might be a little bit bigger than these two. So either you have one or two cylinder at that location. Probably it's just a matter of uh, choice in your design decision. Sometimes you have smaller size component, but you have two, and instead of having one that are bigger. So that I hope you understand. But when you have that duplicates, you only count one of them. Okay. Nanti ada tanya cakap kat saya, oh, tapi Encik dia ada dua, satu sebelah sini, satu sebelah sana, satu sebelah kanan, satu sebelah kiri. So, but they are actually doing the same things, just a mirror image of the other one. So we just count one of them in our mechanism or kinematics consideration. Okay. So, like I said, when we look at it from the mechanism or kinematics perspective, we don't care about the details of it, the shape, the size, that don't matter. What we concern with the what type of elements, and sometimes what we should be considering is also the length. Length does matter. Length does matter. but the size, how it is going to be powered. So those are concern in mechanical design. So mechanical design, we will concern about that thing. What material we want to use, whether it's going to be strong or weak. So those are in from other perspective. But from the mechanism perspective, we need to know what is the type of it and also what is the length. So length is sometimes should be our concern. Okay, do you have any question? I will try to go slow. If that turns out to be boring you, bore you to death, I'm so sorry about that. Sometimes for I have to also consider the majority. Maybe some of you need to be taken through this very slowly. And also, I like to kill the time. Otherwise, if I go very express, I'll end this class very, very quickly. Perhaps you want to end very fast because you want to go to Bazaar Ramadan. You want to do that, Budiono? Okay, too early to go to Bazaar Ramadan. All right. Are you guys still with me?
Yes, Doctor.
Yes, Doctor.
All
Stay
right.
with you.
Yes,
All
Doctor.
right. Anybody want to share some joke or something like that to spice things up? Okay. Let's move on to this next slide. So it's called the kinematic diagram. So um, basically, sometimes it's harder for you to, to analyze it when things are looking like this. Okay, but sometimes you have to after understanding the basics, I guess you can just work on it by just looking at this thing. But maybe for a lot of other people, they have to simplify things up. So that's something that we should be able to do. So for example, take this car wiper, front windscreen wiper. Uh, so you have the motor connecting to this part to turn to operate this windscreen wiper. Okay, so you see from the middle arm over here, you have two other arms to the left and right, and that will be connected to to the real wiper, to the real wiper. And usually the wipers are of different sizes, and so you want to convert this real thing into something that we call kinematic diagram. So the reason why you want to do this is to simplify things. So usually in this kinematic diagram, the length is not taken into consideration. Okay, so usually the length is not taken into consideration, but maybe they should. I don't know. So here uh, when we do this, this part you can represent over here is the motor, where you can locate the motor, and the motor can be connected directly to the short arm over there, short crank. So the part that rotates with the motor, we call it the crank. Crank, crank, the crank. So the crank and then have a pin. So a pin that have connected to the green links over here, to the right and left, right and left, and this right and left green links needs to be two separate links. So there are two separate links. There cannot be one link, because you need to have some relative movement between them, and they need to be able to rotate about a certain pin. Okay, so physically we have one pin that connects three links here, this one and the other two. So three links sharing the same pin over here in the middle. Then you have this wiper blade. Maybe the blade part is this part, the point of interest. So the frame of the wiper will be this part. Okay, so that needs to be connected to two points, two pins or revolutes, and this other part is the point of interest, especially the tip of it. Okay, so why is it the tip needs to be the point of interest? Because usually you want to track um, that position, because that will uh, will determine the coverage of the wiping of the wiper. How far or how far is the uh, space, or how far is the area on the windscreen that is being wiped or covered by the wiper. Okay, and also you want to track whether the wiper is protruded beyond the windscreen. Because if you bought or installed the wrong size, maybe it's too long, so it might go beyond and hit other people lah. Motorcycle lalu sini kena muka dia, dia awak kena saman. Pernah ke terjadi macam tu? Okay, ini secara teori lah. So that's why you need to track the point of interest lah. Okay, so sana ada siapa yang naik motor dekat awak punya helmet ada wiper? Saya tengok ada ada helmet yang ada macam tu, ada wiper. Kita boleh install battery operated wiper. Ada yang pakai macam tu. Boleh consider lah. Mungkin kat Shopee ada temu. Anywho, the next example, even for very simple scissors here, very simple scissors, you can also break it into kinematic. So it's going to be very simple. So you can decide one of it to be the frame. So for example, the black one here, I consider it to be the frame. So that only this gray part is the moving part. Gray part is the moving part. So which one is the handle? Say this one is the handle, and this one is the sharp edges. Sharp edge. One. This also. So even though in reality, when you operate these scissors, both ends here will be moving, but just for the sake of kinematic consideration, you assume that this part is connected to the ground, and only this part will be rotating to operate these scissors. Okay. Okay, the way when you want to draw your kinematic diagram, when you have this part and this and here is the same body, so that is represented by maybe this and this. So you need to have a jump around the pin. You need to have a jump. So either you have this semicircle jump, or you have this more square or rectangular jump over there. You know what I mean? You know what I mean here. So when you have this in your drawing or in your sketch, that means this part and this part is the same body, on the same body. Okay, one piece. Okay, like this part and this part. one piece. Okay, as opposed to this one, when you do not have that jump, that means this and this are separate. Okay, it's not the same body. So this is one piece, this is not another separate piece. Okay, so that is the meaning of it. That is the meaning of life. Okay. The next part that will be used in the future when we talk about an equation, which is called the Kurzbach modification of Grubler's, or simply the Grubler's equation, is you need to identify the number of links and also joints. Okay, so joints that we consider are J1 and also J2. So that's why earlier we talked about how to categorize the type of joints. How to categorize the type of joints. So you must know which type of joints fall into the J1 category and which one fall into the J2. Okay, so number of links. So in this case, the frame, this body in the black is considered as number 1, and the one in the gray is number 2. So hence, our n is 2. Okay, this whole thing is one body, and this other whole thing is another body. So that's why it's a two body. So always, and we have to always count the ground. So if in actuality both are actually up in the air, you can hold it by your hand. It's not connected to the ground, but for this analysis, you have to consider at least there must be a frame or there must be a ground. So you choose either the top part or the bottom part to be the ground. And then how many pins? Only one pin. That is a revolute joint over here. So that's why our J1 is 1. Any question here? This is very easy example. Okay,
No,
ada
Doctor.
nak anybody want to argue why this is like this? Why our n is 2, J1 is 1? Anybody? Anybody dare to oppose me? No, just kidding. Just kidding. Okay, and then back to this one. Back to this angry looking pliers. So I can, since I said, let's define this top part as the ternary. So hence you can draw it as a triangle like that. And this jaw, lower jaw is also a ternary. So draw another one like that. It doesn't have to be that beautiful. Then this gripper, lower gripper, also ternary. So draw another. So it doesn't have to look exactly like this one. Just a representation of how this thing works. And then you have this part with a notch. I don't know what's the use of this notch. Must be some use for it. But since what matters is this is a location between this point and that point that is covered here. So just draw it as a binary link. So that will be binary link. And usually you want to number your elements. So the first one, and I declare that the top part is the ground. There should be at least one, at most, at least one ground. Ground kira satu lah. Anything that is connected to ground considered as one ground. So that is the ground, and label it as number 1. The lower jaw, label number 2. So label by number lah. And the next member or link is number 3, the gripper, and then the link in the middle is number 4. Okay, and then take a look at joints. So it seems to be all J1 joints, or we see only only revolute joints here. So A over there. So here we label by lowercase letters. We use lowercase letters, huruf kecil. And then point over here, that's B. This over here is C. And over here, that is hidden. So that is D. Okay, so this is the simplest representation or kinematic representation of these pliers. Actually, we do not consider this part now. But if we want to consider that, so the sketch over here will be a little bit different. But save that for later. Okay, so 1, 2, 3, and 4. So hence our n is 4. As for J1, we have A, B, C, and D. So that sounds like a 4. And J2, how many J2s that we have? As ourselves, do we have any gear? No gear. Cam, no cam. Screw. Actually, there's one screw here, but since we disregard that part, so let's say there's no screw. And then is there any pin in the slot? There is no pin in the slot. So our J2 becomes 0. Any question over here? Tak ada. Dah lapiak?
Tak ada doktor.
Tak ada. Azan Zuhur pula. Buka puasa. Ya, nah, tengah Ramadan. Alright. And then let's take a look at this clamp that we saw earlier in that animation. We can represent it to be like this. Okay, the front part, this one. And actually, when you see this, it is a ternary link. So this is the point of interest. This is second point, and this is another point for pin. So 3 points that are important for this body. So it is a ternary link. So you can either draw like that or draw like a triangle. So this part over here, 1 point, and the third point is where you handle, or where you put your finger or your hand to operate this clamp. And then not seen here, but if you look at the animation, there should be a very small link, binary link, and that one will be over here. So it's not seen here. So sometimes you have to look in the bigger picture on how this thing works, so that you can identify all the components or all the links in that machine. So this is a machine. Okay, so and then you start counting and do your labeling. So the ground, this piece over here will be the ground, and actually you can see it can be bolted or screwed to the table or frame, something like that. So this is considered as the ground. Okay, so you see there are 2 points here that can be considered as connected to the ground, but you consider them as the same ground. So same ground. So it's not one on one body, one frame, and the other one on another frame. No, they are on the same frame. So that's why all the ground is considered as number 1. So number 2 depends lah. You can label this number 2, number 3, and number 4. Or maybe you look at the output as number 2, this one, number 3, and this one, number 4. So what matters is the total number. Our n is 4. Then J1, so we have 1, 2, 3, and 4, label A, B, C, and D. So this is a 4-bar mechanism. So usually you'll see the n will be 4 and J1 will be 4. And there is no J2 here. So this one will be the last one to maybe this one will be the last one for us to consider for now. So this one will be more complex. So this in this backhoe or JCB, we call it backhoe lah, backhoe. So you look into this component part lah. So even though this thing can swing about this axis, but we just consider this subsystem. So here, as you can see, you have to represent it in this manner. So you have to identify how many points in each of the body has. So this boom that has JCB written on it. So you have 1, 2, 3, and actually there's another hidden hydraulic actuator back there that for some reason is hidden. So it is like that. So there'll be 1, 2, 3, and 4. So that's why this boom has four links, 4 points. And then this second boom, we have one boom, one pin, 2, 3, 4, and 5 here. So here we have 1, 2, 3, 4, and 5. And then you have this ternary link over here. This small looks like an L. So L has 3 points. So you have this ternary link. And actually down below here, connecting to the bucket, you have another binary link. And then you have the bucket. So bucket is also a ternary link. You have 1, 2, and another point of interest. So you need to know what's the tip of your bucket so that you can track, and you want to track that whether you have arrived at the right location or not. Okay, and you see the hydraulic cylinders are also important. You have to take them. Those are also rigid member of the system. You have to also include in this kinematic diagram. So how many hydraulic cylinders do we have? We have 1, 2, and the one hidden over there. So 3. So 1, 2, and 3. And these hydraulic cylinders are broken into 2 parts: the cylinder part and also the rod. So you have to represent the cylinder part and also the rod. Cylinder, the rod, cylinder, the rod. Okay. So those needs to be clearly defined as 2 separate rigid body. Okay. And this one works by sliding. The rod slides inside the cylinder. Okay. So this is a bit messy. This is going to be messy, not Lionel Messi. Okay. Any fan of soccer or football? So this is messy in terms of can be difficult to trace. But this is basically the kinematic diagram, and you have to hook them up very correctly, carefully. And then label. Label is also important. So you have to label. So all the ground here labeled as one is the same ground or same frame attached to the same tractor. So it's not like one the top part connect to one tractor, the bottom part connect to another tractor. So it doesn't work that way. Connected to the same vehicle. So that vehicle is considered as the frame or ground. Okay, and then this is link number 2, number 3. So counting the big items first. 2, 3, 4, 5, 6, then 7 and 8, 9 and 10, 11 and 12. Okay, 12. 12. So hence our n is 12. So J1. So J1, J1, J2 is definitely 0 because we don't see any one of the 4 items. No gear, no cams, no screw, no what's the other one? Pin and slot. Okay. So as long as you don't see any of the 4 things, so our J2 will be 0. So all our concern is just J1. So J1 can be sliding or turning or rotating. Okay. Okay, you have A, B, C, maybe this D, A, B, C, D, A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, O. Okay. So up till O, from A to O, so you have to count how many alphabets are there from A to O. A, B, C, D, E, F, G, H, I, J, K, L, M, N, O. So it sounds like 15. So 15. Okay, so if you see here, 3, so this is what we call the uh, KMNO, KMOGE, or the Groblus equation. KMOGE stands for Kurzbach modification of Groblus equation, or just call it Groblus equation. Maybe some people call it Kurzbach equation, but I guess the original one is called the Groblus equation. But then it's being modified by Kurzbach. Maybe just call it Shamsul equation or Anwar's equation. No, I'm just kidding. So finally, the final format that we use is this one. Let's see if we this one. F equals 3 times n to the minus 1, n minus 1, 3 times n minus 1 minus 2j1 and minus j2. Okay, so this is to find the degrees of freedom, or we also call it mobility. Okay, so all those drawing or sketching the kinematic diagram is for you to be able to identify our n and also j1 and j2, and so that you can use that to calculate your how many degrees of freedom being involved. Okay, so I guess this is a good place to stop. Let me get out of this presentation. Let me also save this bad boy. And how do I get back to the end the presentation. Stop sharing. And so how do you guys think? Is it interesting topic to study? So it's about machine. I guess you guys love machines. That's why you guys in mechanical engineering. Am I right?
Yes, doktor.
Okay, boleh. Adakah
Boleh,
pelajaran hari
boleh.
ini membuatkan anda nak berbuka? Belum lagi belum
Rasa
lagi.
macam nak sahur lagi, doktor.
Nak sahur lagi. Okay, jangan. Ugi. Okay, adakah anda faham? Sila komen. Boleh.
Faham, doktor. Tak ada masalah. Semuanya senang lagi.
Okay, alhamdulillah. So that's the spirit you want to see. And of course, if you see it, probably something that you can utilize in your final year project, or in any other aspect of your, if you have some personal DIY project that you want to do, probably you can also use this thing to understand. So basically, mechanism that we are interested in is all the machine that can move. So usually it's like that. So ada mesin yang tak bergerak. Komputer pun mesin juga. Dulu saya punya profesor cakap, don't forget to bring your machine. Saya, mesin apa lah ni? When he was talking about the computer, my laptop as a machine. Probably there's a lot of some moving parts inside the laptop. Okay, so let me see, how do I get the attendance from here? Can I get the attendance? Meeting record. But usually I just consider everybody to be in attendance. Oh, I have Patterson also taking this class. Okay. So I hope you guys start to have some interest in this subject or in this class, and I wish you all the best. Again, welcome back to this semester, and our next class will be on Thursday, right? Thursday afternoon, kedua. Okay, so I'm not sure whether we can use the same. Probably I have to share a different link for our next class. So you folks have a nice day. Take care, and petang nanti selamat berbuka lah pada yang Muslim. Okay, thank you for coming to the class. You guys have a great day. Assalamualaikum. Bye bye.
Salam. Thank you, doktor.
Okay,
Thank
bye-bye.
you, doktor.
Thank you,
You're
Doctor.
welcome.
Thank you, doktor.
Thank you,
Okay,
doktor.
thank you, doktor.
Thank you, Doctor.
Thank you, Doctor.